Okay, so in this lesson, or in this worksheet rather, um, you want to use the leading coefficient test to determine the end behavior of each of these polynomial functions. All right, so all these are polynomial functions. We discussed this in a previous lesson. So remember, in polynomial functions, the graphs are smooth curves, looks like this. All right, they're continuous. There are no breaks. There are no sharp turns. They're just smooth curves. Okay, like if you're driving on a highway and you didn't make any sharp turns, or you didn't run off a cliff or something. Okay, so that's what polynomial functions look like. Now, in order for it to look like this, though, the degree has to be 2 or bigger. All right, so we're only looking, if you look at these, all the degrees, the degree of this polynomial is 2. Remember, the degree of a polynomial, you look at each term, and then find the degree of each term, and then the larger degree is the degree of the polynomial. So the degree of this polynomial here is 5. The degree of this polynomial is 7. And the degree of this polynomial is 4. All right, so when discussing the leading coefficient test, you are going to have to look at the degree, the leading term. Okay, so the leading coefficient test, first of all, you can look at the leading term. So the leading term would be the term that has the largest degree. So in this case, it's this one. Okay, so then you ask yourself, well, is the degree even or odd? So this is even. So we're looking at an even degree. And the coefficient is negative. Okay? So if the degree is even, remember the degree is even. If the degree is even, either the end behaviors. So remember, we are talking about the end behaviors here. So these are, remember, end behaviors. So what happens on the outside? I don't care what happens in between the end behaviors. It's what happens on the outside. That's what the leading coefficient test talks about. So the end behavior, if the degree is even, will either go up, or the end behaviors, they'll go down. Okay. So I know that on both sides will be pointing in the same direction. So just think same direction. Okay, same direction. But the degree here is negative. Degrees here is negative. So think about negative x squared. If you have to, think about negative x squared. Y equals negative x squared. So you know that this is even. The coefficient is negative, so you know that it goes down. All right. So when dealing with even degrees, think of this. If this were positive, if this was a positive x squared, it will go up. Okay. So that helps you with the even ones. So in this case, you would say this. So I know it's going to go down. So you're going to say the end behavior. So when we talk about the end behavior, so the graph goes down or falls. You could say graph falls on both ends. Okay, or I can say the graph falls on the left and right side. Okay, something like that. All right, now let's look at this one. So here, first of all, we got to make sure we know which one's the leading term. So my leading term here, my leading term in this one is the one with the larger degree. So that's this one here. So the leading term is 3x to the 5th. So the degree is odd, so that's an odd degree. So remember, with an odd degree, something like this. This is odd degree. So with an odd degree, the end behaviors are in opposite directions. So end behavior are in opposite directions. Okay, and remember, when to help you with this, think about I'm going to do that here. Think about y equal x cubed and y equal negative x cubed. So in a previous lesson, when we graphed this, the y equal x cubed looks like this. Okay, and then y equal negative x cubed looks like this. And so if you look at the end behaviors, so since remember, this is positive coefficient here and this is negative, so for odd and positive coefficient, it rises on the right, falls on the left. With negative, it rises on the left, falls on the right. Okay, so that's what you want to use. Okay, so here I have an odd degree, coefficient is positive. So in my mind, I know it's going to be this idea right here, the end behavior. All right, so in my mind, I know that it will look something like this. So on the right, it'll do this, and on the left, it'll do this. All right, so you're going to say rises on the right side and falls on the left side. Okay, I don't care what happens between them. That's not what the leading coefficient test talks about. It's just what happens in the ends. Okay, over here, we got to talk about what the leading term is. The leading term. So leading term is the one with the larger exponent, with the larger degree, excuse me. So that's this one here. So that's a negative 5x to the 7th. Make sure you're careful. It's not 5x to the 7th, it's negative 5x to the 7th. And it's not 3x. So the leading term doesn't necessarily mean it's the first thing you see. The leading term is the term with the larger degree. Alright, so this is odd degree, negative coefficient. Okay, odd degree, negative coefficient. So in that case, it rises on the left, falls on the right. Okay, so rises on the left side, falls on the right side. Okay, all right, next one. We have this polynomial function. Let's talk about the leading term. Again, the leading term is not 3. The leading term is a term that has a larger degree. So that's this one here. So that's 3x to the 4th. 3x to the 4th. All right, so the degree is even, and the coefficient is positive. So as the degree is even, you know they're going to point in the same direction. Since it's positive, we'll be pointing up. So do this. Okay? Do something like this. All right, so I don't care. Again, I don't care what happens in between them. So all you have to do here is just say rises on both sides. That's all you have to say. Or you can say, you can be a little bit more explicit. It rises on the left, rises on the right. Okay? All right, so that is the key to this worksheet on the leading coefficient test.